Hello, everybody. Thank you for joining us today. My name is Yugaso, and I am a volunteer with Delta Analytics in the Global Teaching Fellows Program. The Global Teaching Fellows Program is an international program that seeks to teach folks. Delta Analytics in the Global Teaching Fellows Program. Sorry, I have some audio feedback. It seeks to teach folks, machine learning practitioners around the world, learning methodologies, pedagoggy, and help them share and teach their own communities about machine learning. And today I'll introduce Cynthia. She is someone I have coached during the program and who's also coached me. And she's going to be talking about her project on learning from Kenyans on Twitter.
Hello, everyone. Welcome to my talk on natural language processing, learning from Kenyans on Twitter. Thank you for the warm introduction, Ugaso, and we can get right into the talk. So a little bit about myself. My machine learning journey actually started in marketing, and I am currently an MSc Social Statistics candidate studying the Kenyan informal sector at the University of Nairobi. And then another thing about me is I love learning, and I enjoy being either the teacher or the student. And finally, I believe that life can be an exciting adventure if you make it once. So I hike and cycle in my free time. You can see me there at Karura Forest. So today's talk will be split into 4 key parts: the problem, the data set, the solution, and benefits of using this solution. At the end of the talk, we will have a few minutes for question and answer. But if you have any questions in the course of the talk, you can feel free to drop them in the chat. So we start with the problem. Okay, so the key problem that we are trying to solve in this talk is that Kenyans' linguistic identity is hard to define. Okay, and to really understand the diversity in Kenya, we need to understand the concept of a language family. So a simple definition is shown that it's a group of languages related through descent from a common ancestral language. So if you look at Kenya, there are 3 key language families: the Bantu Niger-Congo branch, the Nilo-Saharan branch, and the Afroasiatic branch. And Swahili, one of our national languages, falls in the Bantu Niger-Congo branch. And as you can see, that language family is spoken by most Kenyans. But in addition to our 40+ indigenous languages, we have other foreign languages, especially English, which is our second national language. And finally, we have an urban dialect called Sheng. So if we look at mass communication in Kenya for the year 2019, we'll find that radio dominates. And when we look at the top 14 radio stations, you start seeing this linguistic diversity. So you'll find 6 of these stations are Swahili stations, then 2 are Gikuyu, then 2 are Kamba, 1 is Ekegusi, 1 is Doluo, and 1 is Nilotic. And finally, 1 is English. So if we are to look at the use of languages, comparing the 2 national languages, English and Kiswahili, you'll find Swahili is quite dominant. And then another thing to note is Kenyan languages change over time, especially Sheng. So we have a musician here called Octopizzo, and when he was interviewed, he said that whatever Sheng you're speaking now, when you go like even for 3 months and you come back, they are done. After a year, the dictionary is expired. And to see this transition, if we look at the word ladies, in 2001, this word was called Mamanzi, but in 2019, it's now called Mayenzi. So because of this linguistic diversity and the fact that there could be changes in the languages as shown by Sheng, our approach has to be language and time agnostic. So we'll find that more and more Kenyans are going online. If we look at the same data, we'll find that online platforms are the third largest platforms used for mass communication. And when we look at how they use social media based on 2020 data, we'll find that WhatsApp is the most dominant social media platform. And there's also quite a number of people who are on Twitter. So when we look at how they use social media, we'll find they use it for three key purposes: for social usage, to connect with family and friends, for entertainment, and for political usage. But for all these number of Kenyans who are online, we don't have good tools that can serve them yet, okay? Because current NLP machine learning can't handle Kenyan speech, unfortunately. If we look at named entity recognition based on Swahili, there's an open source model called Robata Swahili, which is trained on a clean Swahili dataset. And you'll find that when standard Swahili is used, this is Methali, it is able to show one of the correct answers. But when we use a more informal form of Swahili, we'll find that it is not able to answer the question as well. And then when we look at translation tasks, translating a simple sentence, you'll find that DuckDuckGo, whether it's on the long form of Wewe or the short form of Wewe, it is not able to translate it properly. Now, Google Translate, when the short form is used, it does not translate it properly, but in the long form, it is able to translate it correctly. Microsoft Bing, unfortunately, did not do well on the translation task as well. And just to bring the point home, if we look at a sample tweet from Twitter, from a satirical account called Kenyan Dictionary, we will find a number of challenges also brought about by context. So the first problem we find is this code switching in the same language. You'll find there's use of slang. And for example, this word, it can be used in a Sheng way or Swahili way, but in this context, it's used in a Sheng way. And then if we look at this word, it's slang as well, but it's a sort of hybrid word where there's a Swahili prefix to show the subject and an English verb. And we have multilingualism in the first sentence and the second sentence. And then we also have use of shorthands, for example, using ukiwai instead of ukiwahi, and using we instead of wewe. So I have a question for the audience. What makes it difficult for a computer to process Kenyan content? Is it A, code switching, B, non-English words, C, answers A and B, or D, the data format? Feel free to answer in the chat. Sorry. You're correct, Yuna. It's both A and B. Yeah. So the correct answer is C, yes, Naomi. And Melisande and Delta Shadow. Okay. So to summarize, you'll find that there are 4 key challenges for understanding Kenyans. The first is code switching. The second is use of slang. The third is multilingualism. And the fourth is use of under-resourced languages. So because of this, we need to create a living language model for Kenya. And so this project had 3 key aspects of its plan. We had the project goals and objectives, the generalizable results that can be used in future research, and the use cases for the solution that we're going to build together. So the second part of the talk is the data set or corpus. And we just want to remind ourselves of the problem that Kenyans' linguistic identity is hard to define. So because of this, a representative corpus from Twitter was selected. So why did we select this corpus, Kenyans on Twitter? Kenyans on Twitter is a decentralized group of Kenyans that use the hashtag KOT to organize and mobilize around political and sociocultural issues, both within Kenya and outside its borders. So Kenyans may be diverse online and offline, but on Twitter, they typically self-identify as one. So use of this corpus is important for the following reasons. First, as we saw with the Roberta Swahili model, a pre-trained corpus can't be used for sentiment analysis of Kenyan speech because there's a high likelihood of code switching and multilingualism. Secondly, Kenyans on Twitter predominantly discuss politics compared to Kenyans on other social platforms. Thirdly, analyzing large amounts of data with either code switching or multilingualism with as little translation as possible preserves context. And finally, we need to be able to gauge the sentiment of Kenyan speakers on Twitter. So we then ask ourselves the question, how was the corpus built? So the first stage was data collection, where tweets that were collected were for the Kenyan time zone, UTC +3, with timestamps ranging from 1st of June 2020 to 1st of June 2021. And you can see the code that was used to do the data collection. So we used a command line tool in Python called Twint to mine the data. Okay. And when we look at this language data set, a large number of the tweets are labeled as English, with the remaining amount being labeled international languages like Turkish, Polish, etc. So the next stage was data pipelining, where there was an initial access point through the command line. And then the data format that we used was CSV file, which can be opened in Excel. And then the interface that I used to interact with the data, like for visualizing it and modeling it, was something called a Jupyter notebook that was run on my local computer, containing blocks of both R and Python code. So it was able to go between the two programming languages quite easily for the various tasks that I needed it to do. And finally, the tweets that were selected were tagged EN by Twitter, meaning they were English tweets. So now that we went through that process of getting the data set, what are the characteristics? So this data set had 27,504 tweets, 26,810 conversations, and 8,320 speakers. So we can see that this is quite a decent amount of data for us to work with, and we have quite a large number of speakers. So if we look at the day with the most activity, that was February 17th, 2021, where 353 tweets were posted. And then an interesting thing that came out from this data was most users tweeted once. And the others who tweeted twice or thrice, there are not as many. There's a very large distance between the people who tweeted once and the people who tweeted twice. So if we look at some popular hashtags, these hashtags let us know that we're on the right track. We find that Kenya, Nairobi, BBI nonsense, Kokazi KE, Maina and Kingangi, COVID-19 KE, Kokazi, lets us know that people are using the dominant speakers of this data set seem to be Kenyan. And then an interesting thing, when we get the first 15 results, we have now some evidence of the code switching that we discussed earlier in tweet number 6. Tweet number 8, there's a deliberate misspelling to show the emphasis, to emphasize size of the number of Kenyans. And then the 15th tweet has Kinyarwanda with hashtag KOT being used as a noun to refer to Kenyans on Twitter. Okay, so I want you to take a moment and look at the top mentioned personas or people and their fans. So take a moment to look at that slide, and then I'll ask you a question. So my question is simple. Are political and media personas popular on Kenyan Twitter? Feel free to leave your answer in the chat. Wow, you are all correct. The correct answer is yes, they are. So we will show you why they are. You'll find that the first persona is NTV Kenya, which is a popular media station here. Then we have a number of government agencies, State House, Directorate of Criminal Investigations, and the National Assembly. We have also Citizen TV Kenya, which is a sister station, which is a sister media entity to Citizen Radio, which was the top radio station with the dominant language being Swahili. But Citizen TV Kenya has programming in both English and Swahili. And then we find also their politicians and prospective 2022 presidential candidates, Raila Odinga and William S. Ruto. We have also the English station, the English radio station that we saw earlier, Classic 105 Kenya. Their Twitter account is quite popular as well. So now we are going to go to the third part of the talk, building the solution and evaluating it. So we've split the solution into two parts, building it and then evaluating it. So because we need to create a living language model for Kenya, this is how the model would be visualized. So our goal is to take an unlabeled set of data and be able to identify categories and put those categories to the data, making it labeled. Okay? But the question is, how do we actually create this model? So there are three key ingredients to build this model. We have vocabulary building, data encoding, and machine learning. And the encoding, in the encoding part, we have two forms of encoding. So we have vector encoding and we have one-hot encoding. And then with machine learning, we have supervised machine learning and unsupervised machine learning. So when we look at the purposes of each of these strategies, the reason why we are looking at vocabulary building is we want to create vectors only from the vocabulary in the corpus. And also a key reason for using vocabulary building is when we are going to be vectorizing the data, these languages and the code switching, instead of trying to clean out the code switching or separate it, it becomes a new language for the machine to learn. And then when it comes to encoding, there's a purpose for the two forms of encoding. So vector encoding allows us to preserve the word order and tweet uniqueness. And one-hot encoding will help us identify tweet sentiment. And then finally, machine learning has three key purposes. It helps us vectorize the tweets. It helps us learn and then predict the sentiment of the tweets. And it allows us to label each tweet as having either positive or negative sentiment. Okay, so I have a question for the audience. Making different forms of the corpus helps the computer understand Kenyans. Is this true or false? Leave it in the chat.
The Global Teaching Fellows Program is
Okay. Okay, that's great. So the correct answer is actually true. So those who said A or true were correct. So when we are looking at vocabulary building, there are a certain number of things that we did. So before we vectorized the tweets, we first converted them into UTF-8 format so that my system could understand those tweets. Then they were made lowercase. Then I removed punctuation but preserved the pauses by adding extra space. And then these tweets were tokenized and tagged. And then finally, now they were vectorized. And each vector had 32 elements. So when we look at one-hot encoding, this is the slightly more manual part. And you'll find that we had, because our goal was sentiment analysis, we decided to look for positive words and negative words, but now look for words that are in the three dominant languages that we saw earlier. So we look for English words, for Kiswahili words, and for Sheng words. And that resulted in us selecting these words. Okay. So the first type of words that we selected were stemmed words. So Swahili is a type of language that works with roots. So you'll find like the verb to like or to love is the verb kupenda. But you'll find you can add the time, the tense, and the person to create different combinations. So instead of trying to look for a specific combination of subject and time, we just work with the root word in some cases, like penda, weza, pendi, ata, and then we add various aspects like the time element. So when you see na in nafurahi, for example, na is simple present and me is present perfect, okay? And the opposite of me is ja, just to give you an idea. And then we also try different forms of a word. So many Kenyans in informal context, instead of saying I am happy, they typically just say I'm happy, right? So we tried to find different combinations of these words. And this is the code that was used to create the features and to do the one-hot encoding. And one surprising thing that I found was out of the 27,000 tweets, only 4,000 tweets had sentiment, which made the story very interesting. And an overwhelming majority of the tweets were positive. So very few were negative tweets. Okay. So we went next to feature engineering the corpus. And when we feature engineered the corpus, these are the features that we selected. So we wanted to identify the user, and identify the conversation. So user ID and conversation ID were selected. And then we also looked at to determine, is this tweet positive or negative, right? And then we came up with a score that is the difference between the number of positive and the number of negative words. And finally, our vectorized data. And because of the data being vectorized, it created its own kind of data set. And so when you look at these features, you will find that they allow us to represent the corpus or the data set in different ways. So the first representation is the data that has sentiment, okay? As you can see, the score is either positive or negative, so indicating there's some sentiment there. And then the second way we represented the data was vectorization of the entire data set. Okay, which, as you can see, allowed us to have that representation. So before we continue, it's always good to check this data that you have against the objectives that you've set out. So I asked myself, is this data preserving context? Yes. Is because it is vectorized. Is code switching managed in this data? Yes, because the code switching forms part of the vocabulary that will form the basis on which the data is vectorized. And 3, can we determine the sentiment of the data? Yes, we can, because when we did the one-hot encoding, it allowed us to pick the words that we are interested in finding if they exist in the data set or not. So now that we did that, let's get to the fun part, modeling. So the first algorithm we'll be looking at, which is very important to this talk, is the Drvec algorithm. So you'll find that this algorithm helps us to build vectors out of each tweet. So it builds word vectors out of the tweet, adds a unique token to each tweet, predicts the word in the middle, and then creates a new vector representing that tweet or that document identity. And the optimization function that is used to keep it in line is an algorithm called gradient descent. So it is good to look at how it works under the hood. So we will work with a very simple example. This sentence is stating, I am with Mzee, meaning I am with an old man or I am with my dad. So the first step is tokenization. So what it does, it sort of takes a vector where I exists in the first position, so it's 1. It does not exist in the second position, 0. Does not exist in the third position, 0. And does not exist in the fourth position, 0. So when we do the same thing for each of these words, they form a sort of matrix. And in this way, we are able to now tokenize these words to preserve the word order in which they appear. And then the second aspect of the algorithm is another task that it does. It sort of tries to fill in the blanks on what the correct answer is. So if you remember broken passages in English, it works in a similar way. So we give 3 words to the algorithm, but we want it to predict the middle word. So I dash with, the correct answer is am. And then am dash mzee, the correct answer is with. And so we have an input called the word vector. And then we have a hidden layer of softmax weights that allows us to find the optimal solution. So this hidden layer, it's not something that you can see. And then the outcome, if we are working with the first tweet, for example, will be a document vector of length n. And then when it goes to the second tweet, this document vector D comes back here and gives information to W. And over time, the document vector is optimized as it's running through all the tweets. and the softmax weights are also optimized. Okay. So this is how this tweet over here is able to be converted to be a NumPy array with 32 elements, okay, aka our vector. So I have a question for the audience. How does the doc2vec algorithm work? Is it A, it encodes the text into word vectors, B, it encodes the text into document vectors, or C, it assigns numbers to tweets? Feel free to answer in the chat. Okay. Okay. So the correct answer is actually B. It encodes the text into document vectors because it tokenizes, and the tokenization allows us to have the word vectors. But now when you feed it into the algorithm, the ultimate output is a document vector. Yeah. So the second algorithm we'll be looking at is the k-means algorithm. So this one is much more simpler than the other one. So you take k number of clusters. So in our task, we would be looking at 2 clusters. So we would pick 2 numbers, 2 starting points, and call them our initial centroid. Then we find the Euclidean distance between each data point and the centroid, and whichever centroid that a data point is closest to, that becomes its cluster. And then when it does that, the algorithm will take the mean of all the data points in that cluster and then make it the new centroid. So it will rinse and repeat either for n number of iterations or until the centroids stop changing. Okay. So now that you've seen k-means algorithms, I want you to answer this question. K-means algorithms sort data using the mean of each group. Is it true or false? N number of iterations. Okay. All right. So the correct answer is actually true. It does sort the algorithms using the mean of each group. So the third algorithm that we'll be looking at is the cut algorithm. And this algorithm typically works as follows. So a CAT decision tree is a decision tree that is meant to answer a series of yes or no questions based on the data. And each node of the tree has a score on it, okay? So the criteria for making a split in a CAT decision tree can either be the error rate or the Gini index. And when you have many of these decision trees, they now form an ensemble algorithm, and that is what we now call the XGBoost algorithm. So when the tree hits the maximum depth, a total score is taken of the entire tree, and then a sum of the sums is taken. So a total of all the totals that we got is taken. And then we are able to get the errors made as the data was moving along the decision tree. And then we would run another round of the model showing the errors from the previous round so that it learns from its mistakes and does better. And then you would rinse and repeat for M number of rounds, okay? So XGBoost actually has two optimization functions. The first one is a regularization function to fight overfitting, and the second one is a gradient boosting to improve the quality of results that the algorithm is getting. So I have a third question for you around algorithms. How many splits does a decision tree in XGBoost have? Is it no splits, 3 splits, 5 splits, 2 splits? What's the answer? Okay, we have our first answer. Anybody else? Okay. The correct answer, drum roll, is actually D, 2 splits. Okay. And you'll find that each of the 3 algorithms I just introduced you to are used differently. Okay. So if we look at the strategies we had, remember the vocabulary building, the encoding, and the machine learning, we'll find that the Drvec algorithm is instrumental for the first and the second strategy. The third strategy, we have the K-means algorithm and XGBoost algorithm. So when we look at the Drvec algorithm, it is meant to be an unsupervised vocabulary trainer. It is run each time the corpus has changes, and it's a vectorizer. Okay? And when we look at K-means algorithm, it is an unsupervised data labeler based on the one hot encoded data that we got earlier that had sentiment. And then XGBoost is a supervised data labeler. Okay? So now we want to combine the corpus and the algorithms, and what do we get? We get this. So that I take my raw tweets here, I look for data that has sentiment based on the features that I one-hot encoded here. And then this is what I will feed into the K-means algorithm for clustering. And then I will get data labels for these 4,038 tweets. Now, separately, I will take these same raw tweets, put them through a Drvec algorithm to have them all vectorized. So the vocabulary will be for all 27,504 tweets. And then we will master the index here. So the index is like the identifier of the data set here for the 4,038 tweets, and we will use them to train the XGBoost algorithm. And then once this algorithm is trained, once this model is trained, we can now let it loose on the remaining values in the vectorized data set, which do not have these indexes. And then now it will learn which tweets are positive or negative just based on the vector encoded tweets. So the outcome becomes 27,504 labeled tweets. So just to recap, I can go a bit slowly. The one-hot encoded data is fed only to the K-means algorithm, but the vector encoded data is fed to XGBoost. So the purpose of this algorithm is just to give us a label that we will tie to this data set, matching each index of the labels with the index of the vectors. Okay? I hope that is clear, but you can ask me any questions if you feel stuck. So now that we've gotten the model, it's time to evaluate the solution. So how can we know that we have the best solution? We have two tools in our arsenal. We have human review and we have accuracy. The reason why accuracy is used is because this algorithm is also a supervised algorithm. So we will look at the first 5 tweets, as you can see, the second 5 tweets that you can see. And then when we label them, this is how I labeled them, having the sentiment, whether it's positive or negative. And in 2 of them, it was neither, it was neutral. So the first experiment we did was to just feed the vectorized model directly to K-means, because K-means is a very good and supervised algorithm. So what are our results? You'll find that the first group has mostly neutral sentiment, and then the second group has mostly positive sentiment. So when we run the second model, where we flatten the vector that I just showed you, that table, and we make it into a long list, and then we attach the user ID feature and the conversation ID feature into K-means, we find that we have different results, but they agree on classifying the first tweet, the second tweet, the third, the fifth tweet, the fourth tweet, and the rest, it comes up with its own classifications. And then when we look at now our approach, the approach proposed by this talk, this is the results that we got. You'll find that all 3 models only agree on the first and second tweet, but they don't agree on the groupings with the others. And you'll find that the accuracy of XGBoost with our approach was actually 62.7%, meaning it got 62.7% of the labels right and the remainder wrong, okay? So then we would ask ourselves, what is the best solution? So if we look at model 3, it is the best solution because it was able to identify majorly positive and majorly negative tweets. So I'll ask you a question. Why was model 3 the best model? Is it A? Is it B, C, or D, all the above? Okay. Yes. All right. So far, everybody is pretty much correct. The correct answer is D, all the above. Okay. Someone was that in as much as the classification is not perfect, it got a couple of groupings wrong. It did well for a predominantly unsupervised challenge. And because adverts that we found among the first 10 tweets used popular hashtags not as intended, like it's advertising mattresses, but it's talking about Ikokazi KE, hashtags were not found to be a very reliable feature. And then another key insight is actually few Swahili and Sheng words were found in the data set, which is very interesting. The sentiment of most tweets was neutral, as you saw. And as I stated earlier, the overall accuracy for the best labeling approach was 62.7%. And another cool thing about our approach is if you compare it to the other two approaches, the labels kept changing. But for the third approach, the labels stayed the same. So what are some benefits of this model? So the first one, it's generalizable. Okay, so if we take any type of data, whether it is text, whether it is audio, video, and we do the same checks, having objectives and tying our features to those objectives, and we run it through these algorithms, vectorizing the data set and then feeding it into these models, this is something that can actually work on other types of data. The second benefit is it's dynamic. So it's dynamic because each time this corpus changes, this data set changes, this model will run afresh so that the vectors that it has here are up to date. So thirdly, it's interpretable. So if maybe we were asking ourselves, why did we get the labels that we got here? We can clearly see how the feature engineering, where the data scientist was involved in creating the features, influenced the clustering of k-means, and then we explain this is where the data labels came from. So if maybe any changes need to be made, we can easily make them here, okay? And not only that, samples from the corpus and the overall distribution of positive and negative sentiment in the data can be used to determine the nature of the groupings. And then finally, it is relevant. And just to see its relevance, I would like to introduce you to 3 scenarios, okay? So I'd like you to meet Kevin. As you can see, Kevin is very busy running behind the scenes of NTV Kenya. And we would like to ask ourselves, what are the benefits of this style of modeling to someone like Kevin? So firstly, it would allow him to curate in a more efficient way Kenyan written audio and audiovisual content, instead of him having to manually watch the videos and then label them, or listen to the audio and then label it, or read the text and then label it. And then another benefit is there are more accurate results from automated media monitoring. there's integration of audience feedback into the media buying process. So because of this labeling, he's able to keep track of feedback online in an automated manner and feed it back into the media buying solution that they will be offering, that his station will be offering advertisers. And then I would like you to meet a business team, discuss in a meeting. So what benefit would this approach be to this business team? So first of all, it would be better automated analysis of customer feedback. So so many companies have such a high volume of customer feedback entering the organization on their social media channels, on media platforms, on emails, phone calls. This approach can help them have better analysis of the kind of feedback they are getting, being able to handle misspellings, code switching, and things like that. And then another benefit is this feedback, not only from customers, but from employers, from investors. It can be integrated in a more automated manner into product development, pricing, and go-to-market strategy. And thirdly, I would like you to meet Moses. Moses is a community-based worker working with local communities in Kenya in informal settlements. So why would this modeling approach be beneficial for Moses? So first of all, as we have seen in the earlier part of our talk, Sheng evolves so fast. So having this kind of solution would allow him to be able, or would allow his organization to be able to track the evolution of Sheng. And because they're able to track that evolution without having an army of people labeling the data, this is the new word, this is the old word, it would help with production of relevant media that resonates with the communities that he would be serving. And when these people go to Moses and give feedback, or when donors to the NGO he works for gives feedback, this stakeholder feedback can be integrated into monitoring and evaluation reports. So what are some benefits of including informal language for language analysis? Is it A, B, C, or D? Feel free to let me know in the chat. Okay. I see the answers coming in. Okay. All right. Okay. All right. So the correct answer is D, all the above. Okay. So we have 3 key points that we want to end this talk on. The first one is we need either more data or more time to grow a Kenyan corpus. So we have 50 million Kenyan citizens, but the data we have is only for 8,000 English-speaking users of this hashtag. So how can we increase the number of speakers and even increase the volume of conversation? So we can add additional data sets for analysis, like Facebook groups, Kenyans on LinkedIn, Kenyans on Instagram. And of course, when we're looking at these data sets, we would like to preserve privacy and work with publicly available data. Okay? So what next? So with regards to this style of modeling, it would be interesting seeing it in different cultures that are similar to Kenyan culture, in the sense that they have multilingualism, they could switch. And then it would also be interesting looking at running this pipeline with audio content and video content. Okay, so you can just see the model for your reference. And then when it comes to this particular data set, we can check out why do so many tweets have neutral sentiment, try to predict political tweets or tweets that have a political nature, and try to predict which tweets are ads or spam. And then finally, we need a solid framework to better scope and implement NLP projects. So I created the NLP Toolbox here and used it in this talk. And the NLP Toolbox is a collection of concepts, tools, and ideas available for building applications that can handle real-world challenges around understanding content from all over the world. And this toolbox is very, very useful. So somebody who's a beginner to NLP and maybe wants to understand where do I start, it's such a large field. And so this presentation and alongside other resources like the notebook that I actually ran to produce the results that I discussed here, you can find them on this folder on GitHub. And you can find also some beginner resources if you want to learn more about NLP. And if you have any questions for me, feel free to email me and contact me on LinkedIn. So first, I would like to thank my incredible coach for such encouragement and support and wisdom and guidance. A big, big, big thank you. Thank you so much to my fellow Delta Analytics, to the Delta Analytics organizers and facilitators. They were so helpful with unblocking me, and some of them are actually in the chat. And then I'd like to thank my fellow Delta Analytics teaching fellows. I have learned so much from you all, and they are also in the chat participating. I really thank them so much. And then I'd like to thank you, our audience, for making the time to actually be here and watch the talk all the way to the end. A big, big, big thank you. And finally, my support system, my family, my friends, God, thank you so, so, so much. So now we are at the end of the talk. Do you have any questions for me? Okay. I can see your question. What are the next steps for my project? So I would really like to flesh out the thinking framework that I used to come up with this talk, the NLP Toolbox, and share resources. And I would also like to see if I can maybe extend this research and experiment with audio and video content and just see if actually this pipeline can work as intended. Yeah. Thank you so much, Khalid and Delta Shadow. Any other questions? Oh, I see your question, whether Yuna, if it can be configured for an institution. Yes, it can. The goodness is because the modeling is actually in Python language, it's just integrating it to a Python backend of an existing institution. I see another question here from Delta Shadow. What was your biggest learning from working on your Delta project? My biggest learning from working on this project was actually improving my grasp of NLP. Yes, the teacher was also learning as they taught. And it was also great meeting such brilliant people who really inspired me to grow in my NLP journey and do more work towards creating awareness around machine learning in Kenya and in other non-tech species. Yeah.
Well, it's 10:02.
Mm-hmm.
If we have any more final questions, now's the time. But I just wanted to thank you so much, Cynthia. You did such a great job. And if anyone else is curious about the program Cynthia and I are part of, you can go to deltaanalytics.org and also subscribe to our YouTube. And you can see other talks there from our previous cohort of international fellows. Oh, we have one more question.
Yes, we have one more question from James. Most Sheng speakers don't use social media. How will you gather more Sheng words or data? So the first key thing that I would require is organizational buy-in, because you'll find, like, for example, our media houses, you'll find that they have quite a wealth of information, and you'll find that also in as much as Sheng speakers don't use social media, we can actually even have like an outreach where we can do like a survey and be able to interact with various Sheng speakers with their consent. So those are just some of the ideas in my mind, but I recognize that it's very difficult having access to that data, and access to data is actually a key challenge that the field of machine learning faces. Yeah.
All right. Thank you so much, Cynthia, and thank you everyone who joined today. After we conclude the live stream, the talk will be available. And stay tuned for more talks from our other fellows coming up in a week. Anything else, Cynthia?
None from my end. Just to thank everyone once more for coming, for participating, answering the questions and asking questions. They're very welcome.
Awesome. All right. Have a great day, everybody.